Hello everyone, thank you very much for joining today. We continue with chapter 5 from Spring Start here, but not before. I'm gonna tell you, I'm gonna actually remind you, have the live chat there. And if you want, you can share me the questions, or as usual, you can put your comments in the live chat. And of course, remember, you can join me online on other social media. Recently, I've started my Discord server, so please join there as well if you want to have a more interactive way of discussing. And I'm gonna just share my screen because I don't want to unusefully take too much of your time, and I know you are here for learning more stuff and commenting with me about Spring fundamentals. And if you correctly remember, in the last episode we finished with chapter 4, and you know we have already discussed the large part of the fundamentals part 1 of this book. So we've been through defining bean, wiring beans. We know how to create beans. Now we know the difference between dependency injection, wiring, auto wiring versus defining the beans. This is very important because many developers, many beginners there make such a confusion as thinking that auto wired is creating the bean. No, we know now that this is not the case, and if this is something you don't, for example, you don't remember, or you feel it's not you are not comfortable enough with it yet, you can anytime go back and review the previous episodes of this same playlist, because all these details are very important. It's very important for you as a Spring developer to understand very well these basic concepts. If you don't understand well the basic concepts, then you cannot understand what happens at a more high level more high level area when we talk about other projects, and we will talk about other projects such as Spring Data, Spring Security, and so on and so forth. This is your target. Knowing this core in this book, it's very important. So what do we discuss about today? This chapter 5, it's still on the Spring context, you see. So I have on purposely named this chapter starting always Spring context, just for you to know that, again, this fundamentals part it splits into two very important things, which is the context itself, which is related to the dependency injection, which is one of the implementation of inversion of control, referring to the relationships between instances managed by the Spring framework. Remember, beans are actually just a fancy name for instances that can be managed by Spring. And the other part, which is shortly discussed here, but enough, let's say, for what you need, is the aspect-oriented programming, which is basically the inversion of control related to the methods. You will see, we'll discuss it very soon, no, because we are already at chapter 5 now, so chapter 6 is just the following. So it's managing the relationships between beans, which I see this as the inversion of control part related to attributes, versus the control of the methods. No, so you have the attributes, you have the methods. It means you have the full instance controlled. That's how Spring controls an instance. This instance that we particularly call a bean, yeah, because that's the name we give to the instances we put in the context so that Spring can control. Let me see if I have questions already. So okay, if after we finish the book we can build projects because we still in beans and parrot. I feel frustrated. I'm not sure what exactly frustrates you. I'm sorry if that's oh, I see, don't real projects. Well, you know what, very many developers are so eager going into that really quick into that real projects, and you know what happens? They go there and they don't understand the real things behind the scenes. So my advice is take a step back, be patient, understand very well the concepts, because you can easily go into a real world project and then you feel lost, or you try to do the stuff just copy pasting from Stack Overflow or today's ChatGPT, Bart, or whatever AI tool, and in reality you don't understand what's behind the scenes. So these examples with Parrot are actually really important. This is the purpose of this book. If you don't like it, no problem. You can anytime go to a more complex book, go to Spring in Action. You will find more realistic projects there. Maybe it's for you. The majority, however, felt that they need to take a step back. And that's why I created this book, is for that majority that wants to take that step back and really understand what's behind the scenes, which will lead them to really understanding the real projects and not just surfacing using copy pasting without knowingly basically what they do and stuff like that. That's my purpose of this book. But again, not all the books are for everyone, no. So I reviewed one of my colleagues' PRs where he put a repository annotation over a JPA repository. So I asked him to remove it. Good, very well done, Georgia. I know that it's one of the things I have said on the Discord recently, and one of the most, but we will get into that when we discuss the Spring data. Now, one of the chapters in part 2 here. It's one of the most common mistakes because, well, sometimes I feel that people just, and that's also related to the funny memes comment related the projects and what's the purpose of this book, and not being realistic enough. No, simply they take stuff from Stack Overflow. I've seen many times on Stack Overflow interfaces, Spring data interfaces with head repository, but if you ask them, they don't understand why they put that head repository there. Okay, so that's an example where using things in a realistic project without actually knowing the simple things like that in a simple way demonstrated is not enough. And that's, I want to now go further with the context of this chapter because it's important to also go through the content of the chapter. This is today's lesson purpose. So bean scopes and the life cycle. So now that we know how to define the beans, how to wire them, and we even know how to use contracts, no, because that's what we discussed in chapter 4, the fact that you can directly link to implementations, but Spring is smart enough to allow you at the same time decouple the implementations through contracts using interfaces where needed. Remember what we discussed, contracts shouldn't be actually absolutely everywhere. That's another anti-pattern. That's an over-engineering. If you start using interfaces everywhere, that's not good either. But we know that in many situations, and those are basically the situations where we have multiple implementations, such as Spring Data, for example, where you have multiple possibilities of connecting to a data source. Interfaces are important because they are a way in which you can force several implementations to respect the same contract, such that you make it simpler for replacement for the user of the contract, for the user of the service through the contract. So that's why we discuss these interfaces as well. Now, we didn't talk at all up to now about how is a bean really, what happens after creating a bean. We know how we create a bean. We know how we have to use either the @bean annotation, or we have to use the one of the stereotype annotations. We know we have the register bean, but in the programmatic approach, we know we have XML as a very old alternative. But focusing now on annotations, it's usually these two ways. So it's either the @bean annotation that you have to add over a method declared in a configuration class, or is a stereotype annotation such as repository, but we have the generic component, service, and controller at the same time, and the composed REST controller, about which we'll discuss later in part 2 of the book. But what really happens and how long does actually an instance stay there? This is also essential to understand for the memory management. So how does this framework manage the memory in such a way in which it doesn't run into, for example, out of memory errors and stuff like that. How is the context allocated? Can you deallocate? Does sometime being deallocated by itself? So all this depends on the scope of the singleton. Today we will discuss only two of them. It's the singleton and the prototype scope. And there are three other scopes that we will discuss in the web applications because they are related to HTTP requests. Those we'll discuss basically here in chapter 7. So I will ask you for some patience until we get into those. Today we discuss only about singleton, which is the default scope of a bean. That means if you don't do anything special, if you don't declare anything special about that bean, it will be by default a singleton. And that's mainly what we have done up to now in our examples. And we have the prototype basically, which is one of the scopes that we will discuss today. Yeah, let's go with this. And first of all, what I want you to understand before we dive into the singleton scope, which is section 5.1, is that singleton, when it talk about singleton here, it is not that design pattern singleton that you might know about. So if you previously have learned design patterns, just to give you some names to make sure you know what I refer to, like singleton, builder, abstract factory, factory method, visitor, command pattern, whatever, observer pattern, and so on and so forth. So these patterns refer to something else, including that singleton pattern that happens to have the same name, singleton, but hey, you have some boost there also called singleton. It doesn't make it the same, no? So point is, singleton here is just the name. Take it as a name of a scope of the bean and try from the very beginning not to link it to that design pattern singleton. Why do I say that? Because when you talk about the design pattern singleton, you usually refer to a way of designing your classes in your app. Yeah, so your, let's call it code-based design, such in a way in which you have a class that selfly manages its creation and makes always sure that there is only one instance which will be distributed to anyone asking for it. So that it's singleton pattern. In a few words, it's a class that manages its own instance creation and makes sure there is only one instance and delivers that same instance to whoever other object requests it. When we talk about singleton in Spring, however, you might have more than one instance of the same type in the same context. So you see where it differs in reality from singleton pattern, and why I tell you try not to relate them, because this is one of the things that creates confusion, especially with beginners from the very beginning, because you will find it strange then that you can actually create multiple singleton instances of the same type in the context, and then you will ask yourself, why is this actually called a singleton? Simply because it's not related to singleton pattern. This is called a singleton because you have a unique name for a unique bean. It just happens that the name that was chosen for this scope is singleton. But you can have multiple beans of the same type in the same Spring context, and they are all of them singletons. Okay, so try to unrelate completely to a singleton pattern, otherwise you will feel confused. Just remember that singleton in Spring means that you have a name, and that name refers to one instance of the bean and only one, and always when getting that bean when requesting that ID, you can call it ID or alias or name, okay, you will get the same instance, okay. So look at this example here, this very nice diagram here. This is the singleton pattern, okay. There is only one instance in the app's memory, but here is the Spring Singleton scope, where you can see you might have two beans of the same type. The only thing different is that they have different names. That's a must. And why it's called a singleton? Because whenever I will reach for common service 1 here, I know that I get the very same instance. But then I can reach for common service 2 and I will get another instance of the same type. So I might have multiple instances of the same type. Very important to make this difference, okay? So look, this is another diagram that helps us understand better how things work, and then we will try it in IntelliJ as well. So we have this comment service, okay? It's over the method in the configuration class. In this case, I just chose to use bean, the bean annotation, but remember, you can use any way of defining beans we already learned about in chapter 2. So it's just a bean definition, okay, but we have defined this bean. Remember that the name of the method is the one that will be used as a name unless we have used the qualifier. So that's why in the Spring context now looks like this, and you see we have a bean with a name, with the name comment service. And then if I try twice to request the bean, the same instance will be provided. And this is why this comparison between the references I have in these two variables here will be always true in this case. Okay, remember that the comparison using the equality operator between two objects compares the references. That means the addresses in the memory, okay? Which means that this is a way to prove that basically you don't have multiple objects, but you actually hold the same reference or to the same object in multiple variables, okay? That's why this will be always true, and you can try it with the examples in the code base. Okay, this is actually the example, and hopefully my IntelliJ will actually work. I haven't checked it before, but normally executing this will do what? Will create the context based on the project config. The project config looks like you've seen in the book. So it creates a bean for a class of type comment service. Name of the method will be used as the name of the bean. That's why I used it here, where I said I want a bean of type comment service identified by this name. If this exists, and normally it does because you have seen it declared as a bean, it will retrieve from the context the reference to that object. Regardless of how many times I will try that, because by default the bean is singleton, and that's what we have just agreed, we will have the same reference here and here, which makes that this comparison to always be true, as you can see in the console of my IntelliJ. Okay, let's see if I have some more questions. So how often do you see multi-threading being implemented within Spring Boot apps? Not very often, actually. I wouldn't even recommend it unless it's really critical to create your multi-threaded architecture for any reason, which I now don't find really one for which you do that. But of course, programming is programming. Scenarios are an infinite of them out there. So in case you really need to have multi-threading, you can do that. Nobody stops you to use executor services, fork joins, parallel streams, and even the low-level thread and thread class with runnable, callable, and so on and so forth, futures and you can do that if you really need it, no? But no, to answer your questions, I don't see that often today. It would be great if you can make a video series on practical uses of Apache Kafka. I totally agree to take actually a playlist for that, and I will schedule one, but once I get a little bit more free, because now I have plenty of things on my shoulders, and I promise you that I really can't do more that I already try to do. Okay, going back to this after answering the questions. By the way, remember you can join the Discord channel if you haven't done that already, because I want to create there a community where we can be a little bit more interactive than on YouTube, which is more like one direction. No, I kindly, it was like this, you write in the chat, I try to answer you, but yeah, it only happens during the live event. Sometimes the questions are not related and I cannot answer them. So join the community for more interaction. Okay, going back now, I'm gonna go back to the book, and I think further we just prove. Okay, let me see. We just prove that you can have multiple classes using this, and now you see in this next example what you do is use stereotype annotations like at service. So if in this case you have multiple beans and they auto-wire a singleton, what Spring guarantees them is that the singleton that they auto-wire, it's the same. So basically, when you declare that layered structure, which I know we are just at the beginning of the book, and as you said, we didn't get into more detailed things. No, you have the repository, you declare a repository, and then you use the same repository in multiple service classes for implementing several use cases. Then you have you actually, what you inject is that one instance. There is only one repository instance if what you have used is the default, which is the singleton. So if what you've done is just putting a repository over the class, and pay attention, over the class, okay, we don't use a repository and neither one of the stereotype annotations over interfaces or abstract classes. It doesn't make sense. And then, yeah, if you have this, now you have the command service and the user service or whatever service, they do refer to the same instance of repository, because there is only one, and you can actually even imagine the Spring context in this case. Now you have declared a command repository and you used the stereotype annotation repository to declare it as a bean. You used at service on a command service and you auto-wired the command repository. By the way, just to make a short parenthesis here, in this case I have used field injection just for brevity purposes. That means because I want to put all this into a diagram, and it was actually very difficult to put it into a diagram using constructor injection. But normally remember what we discussed in the previous chapters. An important advice is that you avoid using field injection and you use constructor injection everywhere in your app's implementation. Actually, field injection is acceptable usually in unit and integration tests, which we will discuss later in chapter 15, which is the last chapter of the book. So with that being said, this is just for brevity, and if you even put this in a modern IDE such as IntelliJ, it will actually show you that it's not advised to use it like that. But going back, so that's what we did. We declared a bean command repository, a bean command service, and another bean user service. So you can now even imagine that you have 3 instances. This is the whole context, is 3 instances. And whenever you inject in one or another, these 2 beans here, they actually relate to the only one here. So both of them relate, they have the same reference. If you would compare this field here with this field here using the equality operator, you will see that it is the same reference. No, it's the same instance in the memory. So let me read some more comments. No, you don't use any more multi-threading thanks to virtual threads? Not necessarily. I mean, virtual threads are a way to improve in some cases, and especially those cases where you have a lot of IO calls, for example, and situations where they get blocked. It's a way to improve the execution, but that doesn't mean that we don't have multi-threading anymore. And situations where we use multi-threading, actually you might even use multi-threading with virtual threads. No, you can create your own virtual threads, and you can define, I don't know, a producer consumer architecture with virtual threads. So virtual threads don't exclude, they are part of multi-threading, and the way in which in certain kind of applications we can improve the execution. But we can talk about that more in other videos. No. And see, here are using the class comment service and comment repository. How would you find where to use the proper class? Not sure I understand, sorry, the question. So this is just an example. Now it's an example where you have, so don't even mind about, see, that's why I normally use parrot, dogs and cats, because using those, people don't mind about what the service is, what a repository says, so on and so forth. So what I want you to look at this example now is, don't actually even mind about what these are. I just want you to understand what a singleton is here. Okay, so you have two beans referring to another one. What I want you to understand is that these two beans, if both of them refer to the same comment service, which was by default made a singleton, it actually refers to the same instance in the memory. That's the only useful thing in my explanation at the moment, because more about the layered architecture, comment, user and repository control, so on, we will talk about in the part 2, when you have already understood all these basics, all these fundamentals. And yes, as I told you from the beginning, I know they might be boring, but trust me, they make such an invaluable thing to really understand how things work behind the scenes. Whenever you work on something, you will be a lot more valuable knowing what's behind the scenes. It's like, I don't know, imagine being a mechanic for cars, no? But the only thing you know is how to drive the car. Are you really a mechanic if you know that? It's kind of that. So if you don't know this stuff behind the scenes, you are not really a mechanic of Spring. No, that's what I want to mean as an analogy. Okay, and then we have some example, and I'm just gonna skip over that because it's the same thing. Let's actually take a look at listing 5.3 here to prove that it's the same thing that we have discussed. Now it's what I was telling you, that regardless on how you declare, if you use it binary notation or if you use stereotype annotations, as long as you don't do anything, the beans will be by default singleton scoped, which means that the two which means that twice, if you take them twice, the two will refer to the same. So you see here what I do, I take the comment service and the user service, service 1 and service 2, okay? And remember, the comment service and the user service, which you can see here in this code listings, they refer to the same bean comment repository, because comment repository is singleton scoped. When I get it and I compare the references, this will always be true, because S1 and S2, they do really refer to the same object reference. Okay, and now we discuss about some singleton beans in real world scenarios. One of the things that, maybe one of the most important things that Spring developers need to know is what happens when you have multiple threads which use the same singleton bean. And you will say, hey, didn't you just tell me that you don't use threads in Spring Boot applications and in Spring applications? Mind that we don't even talk about Spring Boot now. So now we are talking about Spring, and that's it. It's Spring Framework here. Even the project, no, the project that you have seen, it's a Spring project. It's not a Spring Boot one. See, no parent here, no Spring Boot parent. I just have added the necessary Spring dependency, which in my case I only need a Spring context, and that's it. So we only talk about Spring. It's very important before diving into Spring Boot. Please try understand the basics of Spring. Otherwise you will not know what happens behind the scenes. Spring Boot comes with so many magical things that you will just end up copy pasting things because they work. You will see that they work, but you will not understand, and you will just say, hey, they work. That's everything I need to know. But that's really not how a professional should. That's not really the mindset a professional should have. No. So because I went into threads, no, and I don't want you to believe that it's contradictory to what I have just told you. Threads do exist in Spring applications, and actually they always exist. It's just that it's unlikely you will create them. Unlikely you will have to use executor services, the thread class, fork join, and so on and so forth. But what's behind the scenes uses threads. Scheduler are threads. HTTP requests in standard applications, they are threads. And even in reactive applications, they are threads. Just that in that case, the way they work is a bit different, and I'm not going to go into details now. But there are still threads behind the scenes, and you always have multiple threads. And that's why I usually I try using the simplest technical example here. It's when you have a standard non-reactive web application, any HTTP requests creates a new thread, and that means that when you have 2 or more HTTP requests concurrently happening, you will have 2 or more threads concurrently executing. Mind that concurrent is not necessarily at the same time. Okay, that's another story. We can talk about that in a different playlist if you want, which is related to concurrency. But they might be or they might not be executing at the same time. But they are concurrent, means they started and they are managed at the same time. So T1 and T2, there are 2 HTTP requests which caused the creation and management of 2 different threads at the same time. They might even be executing concurrently, meaning you might have these 2 threads instructions at the same time executing, just because they are executed by different cores of the system where the app is running. Because of that, you might run into race condition scenarios. Race conditions happen when threads, 2 or more, executing at the same time, try to access and usually modify, because reading usually doesn't create race conditions. It might create serialization in some cases, but race condition is when you modify. So T1 and T2, they try to change the same object instance. Because we have learned that when you use singleton, reference, like going back here, no? Reference from comment service and user service go to the same single instance of comment repository, because that's what singleton scope means. It means that if you have a HTTP request using comment service and another HTTP request using user service at the same time, and in a way or another, the operation, no, the action running tries to change this instance, then you might run into a race condition because both the comment service and the user service being executed on two different threads will try to change the same comment repository. And that's, my friends, why we never use mutable attributes on Singleton instance. What does mutable attributes mean? It means attributes that are non-final and can and are changed during the execution. Never do that with Singleton beans. Okay, and remember, Singleton beans are always those by default. That is why it's really important to have immutability. It's one of the reasons, one of the two important reasons why immutability is important. The second one is because it helps you create a simpler flow for troubleshooting later, and later implementation and troubleshooting, meaning it enhances maintainability. I won't go into detail about that now, but we can talk about this in other discussions. But immutability is critical here also because in this case you might even create dysfunctional applications. Race conditions, meaning the possibility, the allowing the concurrently change of the same resource, same instance in this case, at the same time, may lead to bugs, errors, meaning usually unexpected output or even exceptions. So we never, and that's why one of the other reasons why as a consequence it's good to use constructor dependency injection. No, we never use mutable attributes on a Singleton with Singleton scoped beans. So when we discuss now what does this actually tell us, so three main points at the very end. Make an object bean in Spring context only if you need Spring to manage it, so that the framework can augment that bean with specific ability. This is something we discussed also in the previous chapters. Many people ask me, when do I actually create a bean? When do I make a class a bean, and when I don't make it a bean? So for example, if I'm going here in this and assume that the service class uses also a model, so it uses how do I explain this without making it too complex? No, let's say this is the comment. No, I made it very simple here. I made it simple especially for brevity. No, but now I have the right to change it to give you some more explanation. Let's say you have this method save comment. No, save comment, and this method save comment, it receives a comment instance as an attribute and does something with comment. Okay, this comment would actually be just a representation of, say, how a table looks in the database, or maybe the body of a HTTP request. When we have classes that whose only purpose is to give the format of the data we work with, we call that model. We say that's a model because it's modeling the data. So in our case, the comment class would be a model. And even here, one more advice, even these classes, wherever it's possible, make them immutable. Today, when we use the latest Java versions, we have records. Okay, here I don't have records because most likely I'm opening the project from the book, which is from 2020, so it's using Java 11. But today we have records. So if it's your possibility, meaning if you work on a high enough Java version and nothing else stops you from using immutability, immutability should be your first choice. It's not always possible. One of the problems would be, for example, like in my case here, I'm using a Java version that doesn't allow me use records. Then I need to create my class immutable by hand if I want. And in other cases, I simply cannot use it immutability because the technologies that I use don't allow me. Hibernate, for example, or any JPA implementation, they are made for mutable entities. That's how it was designed from the very beginning. That will not change. So in that case, I cannot use immutability. But wherever is possible, my advice is immutable first, okay? So going back to my explanation, I will make it a class because it's not that important for the moment, no? And this class is a comment. This class is, sorry, this class comment, it's a model, and say it has some text, which is the text of the comment. Question is this something that should define a bean in the Spring context? Or how do we know, how do we decide when a class should be a bean and when it shouldn't be a bean in the Spring context? And is that relevant? Is that important? Does it affect somehow if I make it or not a bean? And yes, it does. First of all, we try to make beans only where really that is needed. If it's not needed to be a bean, it's better not to be a bean. Remember, being a bean, it just means that you allow Spring to wrap it with different mechanisms for the inversion of control purposes. Spring, as we will discuss in the next chapter, usually uses proxy for that, either using the JDK interface proxy or using CG lib. But that means some overhead. So if we don't need that overhead for the app's performance but also maintainability, it's better not to use it. So wherever it's possible, we prefer to have a class as being not a bean rather than a bean. A bean should be only in the particular case where we need Spring to augment it with something. That's the rule. So how do we know? Well, it's simple. Do you use any Spring mechanism in that class? Is there anything, any reason why Spring would need to intercept this class? Do you use dependency injection? Do you use transactionability? Do you use certain logging, aspecting, security? Anything of this, usually if you do that, you see annotations of any kind. For example, if I would have some auto wired here, I would know I need Spring for auto wiring. No? If I have transactional, I do try using Spring for transactionability and so on and so forth. If you don't have anything, it means you don't use it. If you don't use Spring, then this should not be a bean. And that's, my friend, the answers. And that's how we decide. So make an object a bean only if you need Spring to manage it. If you don't have any requirement to any capability that Spring would augment over that class, then it should not be a bean. And then if you need to make an object bean, so say you need to make it a bean, it should be a singleton, and it should be a singleton, then it should be immutable, okay? So that means make sure that you have no way of changing the attributes, and never implement singletons where different methods change the attributes of that instance. Because in that case, different threads may inject the same bean, they will try to change that attribute, that unique resource, and that's what we call a race condition, which creates usually problems such as output bugs. So very important, singletons need to be immutable. Avoid designing immutable singleton beans. Then if a bean needs to be mutable, and then is what we will discuss in section 5.2, we will have to use a different scope, which is called the prototype. So the prototype scope, which is the other scope, that is the scope we can change our bean into when we don't want it to be the default singleton. We usually do that because we need to have mutability, but at the same time we need Spring to augment with certain capability. So how do you decide? It's simple. When you need Spring to augment your instance with certain capability, then it needs to be a bean. We know already that since chapter 2. Now we know that only beans can be managed by Spring. So you need to make it a bean. But if you need to make it a bean, and at the same time you need to make it mutable, then you have a problem, because if you would keep it as a singleton, as we discussed, you would get, when you have multiple threads, into a race condition. So that's why prototype scope comes to the rescue, and that's what we will next discuss. But before diving into prototype, let's completely finish with what the singleton really is and talk also about the life cycle and not only about what it is in general. So what I mean by that is, let's talk about the most important thing, which is how and actually when is that being instantiated? Why is this part of, let's say, the part of the life cycle so important? Is because it might affect the way your application executes, and in certain cases it might create even performance issues that you want to avoid. So by default, because there is a default as usual, Spring provides with a default, and then as any framework it allows you to override that default. So by default, bean instantiation, singleton bean instantiation is eager. That means that when the context loads, in our case here on this line where you create a context, this is exactly when the beans are created. Okay, so if I'm going to run this, say I'm going to put some system out here with a smiley face, and then I'm gonna go to any of my beans. It's like not important at all which is the bean we are referring to, because we have created all of them as being singleton. And say I'm going to define here the constructor, which we know will be called, and I'm writing here comment service created. What we should see is that comment service created will appear before the smiley face. This is the default, So if I'm going here, run it, it will be comment service created and then the smiley face. Why? Because here when we instantiate the context, this is also where all the singletons are created. This means eager. Eager, it's create them before, even if we know them or not. So that's why all the beans are created before finishing the instantiation of the context itself. When you have the context, you have all the singleton beans by default. This is eager. A disadvantage with the eager approach, which is the default, is that in a big application, you might have cases where you create instances of beans that are never used. No, because if you have a big monolithic application, and that's not necessarily a bad application. No, it's just a big monolithic. Let's say it's actually a one that has been correctly written, it's modular, it's fine, but it's big because monoliths usually grow to be big and with many capabilities which are not necessarily always used. Then what happens with the beans that have been created if they are not used? Nothing, but they will just stay there, occupy space in the memory, and basically just consume resources without being useful. And that's why sometimes we think about how can we avoid situations where we spend resources without bringing us something useful. So that's one of the things. There is one more actually. If you instantiate it at the class, if there is something at the creation of the content, if there is something that that takes long when the instance is created, it's not usually good to put them in constructor, but I don't now. Usually we use a post construct for that, but I don't want to put too many things on your plate now. So let me try to do something here. I was just simulate something like thread sleep. More even, no, 10 seconds, no, 10 seconds, okay? So this simulates something taking long for a bean creation. What do you think will happen now when I'm running this? Just because that bean, which might be the only bean for which something like this happens, the entire creation of the context will be delayed and the smiley face will appear here only after 10 seconds. Okay, so when I'm running this, normally we will see the smiley face only after 10 seconds. I intentionally left the comment of creating the service above to see that it started. No, but you see it still takes time, and only after 10 seconds the others appeared. And that happened because the whole context could not have been created, the finalization of creating the context, before all the beans have been created, because they are eager and singleton. So that's why the app was stuck on this line, waiting for all the beans, including ours, which takes long to be created. So what if I don't necessarily even need that bean and it actually occupies space in memory and takes time to be created? Well, there is an alternative. The alternative is change the instantiation type from eager to lazy. And fortunately for us, it's quite easy to do that because the only thing you need to do is using an annotation, which is quite easy to remember. It's called lazy, and you do use that at the exact place you create the instance. So if you create the instance using stereotype annotations, you will put it together with that stereotype annotation. If you use it together, oh, here's a small bug in the book. No, something went wrong here. Anyway, I will notify the editors. So if you use the add bean, you put it together with the add bean. Now, if you do that, your bean became lazy instantiated. So if I'm going here to my example now, and I'm back to the comment service, which takes long now, I'm gonna put the lazy annotation here. then I will run again the application, and what we will observe is that the smiley face appeared before the 10 seconds. It appeared. Common service created appeared as well before. I will explain that immediately. Now it still takes 10 seconds. 10 seconds, and then the app has finally finished, and you have the true, which is the system out on the line 20 here. Why did it execute like this? Because being lazy now, this line has finished before the command service creation. Lazy means now the bean doesn't create anymore with the context. It just registered that it will be created only if needed, but the creation of the context can proceed without waiting for it to create. It will actually not even trigger the creation. In our particular case here, because we also have another bean user service, what happened on this line is that the user service has been created because it hasn't been annotated with lazy, so it's still eager. But the command service hasn't been created because being annotated with lazy made it a lazy instantiation, which simply registered it, and Spring knows I will create this instance in the context only when requested. So that's why this smiley face was actually displayed, because up to this line 13, the real creation of the command service class didn't even start. When will actually this application create the instance of type command service? At this line 15 here. Why? Because this is the first line that requests the command service class in a way or another. Either with the getBean method directly taking it from the context, or it might have been an auto wiring somewhere. Any place where where the application ends up needing the instance of type command service, that's also the place where the instance will be created. And that's why we had to, this one was displayed after the smiley face, and then we had to wait for 10 seconds. Because at this line, the instantiation started, and it takes 10 seconds because of my code here to finish the instantiation. And only then it created, it took this other reference. This pin was already created now because it's eager, and then also displayed the result of the comparison here. So this is how it works. And now, of course, let's recap the advantages in this case. The advantages in this case are that if you know that certain objects might probably rather be not used, so you have a chance that the execution of the application might not touch them rather than touch them, then maybe it's a good idea to mark them as lazy, because in that case they will simply be created only if they are needed, which is good, meaning that they will not consume resources for creation, and they will not consume space in the memory if they have never been used, and they will never be used. And if they are really needed at some point, then the application will create them. The disadvantage of using lazy is that you move the creation into the execution flow. Instead of having it at the initialization of the application, no, you now move it at the usage itself. Why is that bad potentially? Because, for example, if you have a web application where access to the use cases is made through HTTP requests, then you don't want to have a HTTP request which suddenly ends up needing the usage of the command service, and then it has to wait 10 seconds for this bean to create because it hasn't been already created. No, you would in that case have a HTTP request that takes a very long time to execute, which is not certainly something that the user would expect. Preferably in these cases, you would like to have these beans created, and the compromise is that it's better they are created at the startup and they spend memory resources rather than introduce a bad experience to the usage, to the user itself. So you see, it's always, no, it's a design and architectural decision. It's a compromise. Like always in software, we have to make compromises. So we have to decide very cautiously if a bean should be lazy or eager. And that depends on more things, and the most important being those that we have discussed now. How often is that being used, but also how, taking into consideration how long does it take for the bean to be created, and definitely then if it takes long, maybe you want to make the compromise of creating it at the startup, so being eager. Now, fortunately for us, in the majority of cases, we will use the defaults. So you will not very often need to make beans lazy. At some point, now lazy, it's also used sometimes to avoid circular dependencies, but that's a mistake. That's a design problem. I don't have more time to discuss it now, but maybe next time we discuss it also, and we talk a little bit more about circular dependencies and the improper use of the lazy annotation to solve, and I put it quote marks solve because you don't solve anything, you just put it under the rug, no? So please do not use the lazy annotation to solve circular dependencies. You will find examples over the internet, like forums and so on, with this being done, but it's not right, okay? It's not a good idea to do that. And I think that's basically what we'll continue with in the next discussion, and we will end it here. We will talk about this, and then we will start discussion about the prototype, which is the other scope discussed in chapter 5. And basically with this, we will wrap up of all the fundamentals one need to know about the Spring context, and we'll be able to go to chapter 6, which is the last chapter of the Spring fundamentals, and which will unleash us all basically the remaining things we need to know about inversion of control. So normally, if you have mastered part 1 of this book, if you understood everything that we discussed here, what's in the book here, you know everything about how Spring implements inversion of control, and this is basically the real backbone of Spring framework. I'm gonna stop now because what's too much is too much and is not good, and of course I'm looking forward to seeing you in the next episode, where we will continue our discussion with the prototype bean scope. Until then, hope to continue talking with you on Discord and other social media, and have a great time for study further. Cheers everyone.